Today's topic is writing linear equations. And when we write linear equations, we're going to write them in a couple of different forms. Probably the most common form will be slope-intercept form. And what we're going to find out as we go throughout the lesson today is they're going to give us a lot of different pieces of information. Sometimes it'll be really easy for us to write an equation. Sometimes we're going to have to take that information and use it a little bit differently, using some of the things that we've talked about leading up to this to kind of help us and guide us to what we need to make the equation work. So once again, we've already seen it a couple of times, and here we see it again. Kind of tells you how important it is. Slope, intercept, form. This is the format that almost always we will leave our answer written as. This is probably the best way to write equations out. In order to write an equation in slope-intercept form, what we've said before is we need two pieces of information. We need the slope. We need the y-intercept. If those two pieces of information are given to me, then life's good, man. We can just put it right into the equation and we're ready to go. But not always is that the case, obviously. So then sometimes maybe it'll be like two ordered pairs or different pieces of information. And we will have to use whatever that is to write the equation and y equals mx plus b form. Okay, we will also have some today that are in standard form that maybe we have to do some changing to it. A lot of different variations of equations today. Okay, so let's start off with an easy one. Slope's given to us, and then an ordered pair is given to us. Okay, but not only do we want to recognize that as being an ordered pair, what do we know about the point 0, 12? It's the y-intercept, right? Okay, if a point starts with 0, it always ends up on the y-axis somewhere. Okay, and so they don't just come right out and say, hey, 12's our y-intercept, but we know that this graph is going to hit the y-axis at 12. So we can take that piece of information and really easily determine that our y-intercept is 12. And so if we were to write an equation for this, that's all there is to it. Okay, but like we said earlier, unfortunately, they're not always going to give us both pieces of information, and we just plug it in, and it'd be nice if all the homework was that today, right? But it's not. So we got to have a little bit more work. Another one they give me slope and they give me a point, but this point is just a random point. Okay, it's not the x-intercept, it's not the y-intercept. There's not really anything special about it. It's just a point that's on the graph. Okay, and we could graph this. We could plot a point and then we could do the slope from it. But really, we're not focused on graphing today. We're focused on writing the equation for it. So if we were to put this into y equals mx plus b form, we know slope, but we don't know the y-intercept. The y-intercept is what we're missing. So if we write out y equals mx plus b again, B is the piece that we're looking for. We know M. And then this ordered pair, the ordered pair is always represented as X and Y, right? And so we know 3 out of the 4 pieces of that equation. We know M, we know X, we know Y, we don't know B. So I can take these 3 numbers and I can plug it right in for Y, M, and X. And then we can solve for B, because B would be the missing piece of information. So 6 goes in for Y. negative 2/3 times negative 3 plus b. Okay, and when we look at this, we're like, oh man, we got fractions, it's going to be hard. Don't get freaked out by fractions. Usually it's not that big a deal. And in this case, all you would have to do is take negative 2 times negative 3, which would be 6, and then take 6 divided by 3, which is 2. Now, could I put that into my calculator? I don't have a problem with that, but that should be something, I mean, we could probably do it really quickly without a calculator too. So that would become 2 plus b. And then we're still trying to get b by itself. We have b plus 2 or 2 plus b, however you want to look at it. We're going to subtract 2 from both sides, and we get b equals 4. So our answer then, we put our slope in for m, and now we know b, so we put b in for our y-intercept, and that would be our equation. Okay, so using slope-intercept form, it's always going to depend on what information we're provided. Another one, and this goes back to some things that we talked about yesterday. Once again, we're going to write some equations here. The first one we're going to do is writing an equation of a vertical line through the point 7, 3. Now, do I have to graph this? No. We know what a vertical line looks like, and here's probably the thing we got to make sure that we remember. And if you don't remember this, you could graph it to help you remember it. But if I have a vertical line, what would the slope of a vertical line always be? What did we say yesterday? The other one. Undefined. Yeah, a vertical line would always be your undefined slope. Okay, and we'll do a horizontal line here in just a second, which is always 0. Okay, and if you don't remember it, or just to kind of understand what's going on here, if we went over 7 and up 3 and said here's the point 7, 3, and I graph that line. Here's one of the reasons why I like to graph this, is because we can't put undefined into the equation. Hello? Yes. Yeah. But if I was writing slope-intercept form, I can't say y equals undefined x plus whatever the y-intercept is. Plus, does this line ever cross the y-axis? No. So we don't have a slope because it's an undefined slope, right? No slope or undefined slope. And we don't have a y-intercept, so we don't have either one of the things that we need to write slope-intercept form. So my equation is going to look a little bit different. But we did talk about it yesterday. When I write the equation of an undefined slope or a vertical line, it crosses the x-axis at 7. All the points on this line have an x value of 7. So my equation here would simply be x equals 7. And that would be it, okay? And that's where I think drawing the graph, that kind of helps me to kind of remember that it crosses the x-axis at 7. So my equation looks a little bit different. Okay, the horizontal line and on this one, let's go through the point negative to 5. I'll just give you a different order pair. Okay, this time the line's a little bit different. The line's going to be a horizontal line instead of vertical. And yesterday, the slope of a horizontal line is 0, okay? Vertical is always undefined, horizontal line is always 0, okay? So we got to make sure we keep and understand the difference between those two. So in this case, we know the slope is 0. Okay, we don't know the y-intercept because we just have some random point, -2, 5. But once again, if you were to graph this, -2, 5 would be something like up here, left 2 and up 5. And then it would be a horizontal line through that point. Okay, it's crossing the y-axis at 5. It's a horizontal line through the y-axis at 5. And so an easy way to remember to write the equation here is it crosses the y-axis at 5, so we just say y equals 5. Hey, now some people would do here, and on this one you probably could do it because 0 is the number. We couldn't do this on the first one over here because undefined is not a number. I could write y equals 0, x plus 5, but do I really need the 0x in there? Not really, okay? It's not necessarily wrong, but it's just like extra information we don't really need, okay? And so that's why we can just get rid of this, and we could just write it as y equals 5. We don't need that. So those are like two special scenarios, two special equations that we can write for a vertical line or a horizontal line. The equations are pretty simple, right? But it's just got to remember the difference between the two and what's what. Okay, on this next one, we're going to write an equation given 2 points. So for this one, we're not going to have the slope or have a special situation given to us. I'm going to give you 2 ordered pairs. Two points, and we're going to find the slope and the y-intercept. We don't know anything right now about this graph other than 2 points, right? So I need to know what the slope is. I need to know what the y-intercept is. I need to know all that information. And so what I got to do here then is got to get through, and here's where we're going to kind of bring in some information, some from yesterday and things that we've already talked about. And what I'm going to do here is I'm going to do this 2 different ways. And the reason, I don't always like to do this, but I do it 2 different ways because depending on who you had for algebra or the way that maybe you've done it in the past, I want to show you there's a couple of different ways to do it. And I don't necessarily care which way you go about doing it, okay? And you know, some of you might choose one and some might choose the other, but we're going to end up with the same result regardless. So the first one, all we're going to use is y equals mx plus b. Okay. We're going to finish out and we're going to start with y equals mx plus b. Well, before I can put it into y equals mx plus b, I have 2 points, but I don't have the slope. What am I going to do to find the slope?
The x1 or y2.
Yep, just the good old slope formula, right? This would be x1, y1, x2, y2. Those two can be flip-flopped if you want to, but that's what we talked about yesterday, is finding the slope of this line. So we're going to go -4 minus 3 over 1 minus 2. That's our slope. Slope is 7. Okay, then we're going to put it into y equals mx plus b, and I can choose either one of these ordered pairs. It doesn't really matter which one. If I had to choose between these two, I probably would choose this one here because there's no negatives, there's no fractions. It's pretty nice, easy numbers to use. This one's not horrible, and it's okay to use, except because it has a negative, that probably would sway me not to do that one. So when we put this one in, I'm going to use the point 2, 3. I'm going to use the slope of 7. And we're going to put it into y equals mx plus b. Once again, this ordered pair is your x and y. And we're going to kind of do it like we did a few minutes ago when we had one like this. 7 equals, or sorry, 3 equals, that's my fault. Seven times 2 plus b. Seven times 2 would be 14, and then we subtract 14 from both sides, and we get negative 11. And that's our equation. And all we used was slope-intercept form. Okay? And some of you might say, well, that's the way I like to do it. That's the way I've always learned how to do it. And that's great. Okay? I'm going to show you a second way of doing it. This one uses a different form of an equation. And I probably, if it was me, and what I would encourage you to do is I would probably encourage you to do it this way. But some of you may have done it this other way in the past. And the reason I say the second way is maybe not the way that I would choose is because we got to use point slope form to do it. And in the past, you might have used point slope form, but college algebra, we just don't really use point slope form, hardly ever, okay? And so because it's not used very often, then I would say maybe start leaning towards maybe doing the first one that we did first. Okay, we have not done this one yet this year, but you might remember this from years past. This is what we call point slope form. If I'm given a point and a slope, this would be a really good equation to use. And in this case, we're given 2 points and we don't know the slope. So it's just based on the information that we're provided. So in order to put numbers into this equation, I need a point and I need a slope. I'm not going to go through and find the slope again, but if I didn't know the slope, I would have to find the slope, but we already found it originally, so I'm not going to go through and do that again because that would be the same process. The slope is still going to be 7. That's not going to change. And once again, I'm going to use one of the 2 ordered pairs, and this would still be my go-to. That would still be the point that I would probably choose to use. If you wanted to use 1, -4, go for it. We're going to label this as x1, y1. And then we're going to plug everything in. Okay, so we're going to go y minus y1. And y1 is 3. So we're going to go y minus 3. And then my m is 7. And then it's going to be x minus x1, but my x1 is 2. So it would just be x minus 2. But almost always, we're going to finish in slope-intercept form. When we first started doing point slope way back when, probably Algebra 1, then sometimes we would just leave an answer in point slope form and we'd be done. But for college algebra, we're almost always going to go to slope-intercept form. That's another reason why I would say that's probably should be our go-to. And so now we're going to distribute the 7. And then we're going to add 3. And we get the same answer, okay? And that's why it doesn't really matter which method we choose to do. Okay, anybody point slope fans? Is there anybody that's going to like say, hey, I got to do point slope? Probably not, right? I mean, I would say probably even in Algebra 2, we kind of started moving you away from point slope as much, but we did pretty heavily in Algebra 1. All right. The other main topic today is parallel and perpendicular lines. Okay, if two lines are parallel, what do we know about them?
Never cross.
They never cross, okay? So, two lines that never intersect in order for two lines to never intersect, that means they must have the same slope. So if two lines are parallel, they will always have the same slope. The y-intercept will be different, but they'll have the same slope. Okay, and additionally what I'll throw on here is vertical lines are always parallel. The reason I put that in as an extra piece of information is because it's not a number, right? Vertical lines have a slope that's undefined. So you might say, well, they have the same slope. Their slopes both whatever. They would both have an undefined slope, but it's not necessarily a number. So that's just kind of an extra piece of information. That they're both vertical, so they would be parallel, and they both have an undefined slope. So it'd be two lines that look like that. They just keep moving in the same direction forever without ever crossing. Okay, the other one is perpendicular. Okay, we use that word a ton in geometry, and then we use it a little bit like in Algebra 1, Algebra 2. When we talk about like two lines crossing, and where do they cross, and what do they form when they cross, that kind of thing. If two lines are perpendicular, anybody remember what it means to be perpendicular?
They intersect and make a 90-degree angle.
Yeah, okay, that's good. Intersect. And when they intersect, they do form a 90-degree angle, okay? So when we draw a picture of this, it would be two lines on a coordinate plane that are crossing. And when they cross, they form that right angle. Okay, now the good thing is that we're not necessarily going to graph this and then have to look at it and say, oh, does it form a 90-degree angle or not? There's a much easier way of determining if two lines are perpendicular to one another. If I said my original equation has a slope of 3 over 8, what would be perpendicular to 3 over 8? Close. You got to do one other thing. You got to make it negative, and you got to do one other thing. Negative 8 over 3. And so we would also have to take the reciprocal of it as well. Okay, so the perpendicular slope is negative 8 over 3. And so what we say is that they are opposite of one another, and they are also reciprocals of one another. So if I know one slope, all I got to do for the second one is I say flip the switch, because you're going to flip it over and switch the sign, and that would make my perpendicular slope. Okay, another thing that sometimes you'll hear, these two slopes have a product of -1. And what that means is if I multiply these two together, product means multiply. If I multiply 3/8 times -8/3, it would always give me -1 as my answer. Okay, and that would be just kind of another way that you could check it as well. Okay, so those are some things about parallel and perpendicular. We're going to do some work and some equations with parallel and perpendicular. One of the first things that we're going to do is to identify if an equation or two equations are parallel, perpendicular, or neither. And so they're going to ask us, this question. It's going to be in a question format, but I'm just kind of simplifying it here. They're going to give us two lines, and we have to answer, are the two lines, the two equations that they give us, parallel to each other, perpendicular to each other, and if it's neither one of those, then obviously we would say neither. Okay. Here's the first one. Y plus 2 equals 5x. X plus 5y equals negative 15. Hey, and it would be nice if we could just look at these two equations and say, boom, there's my slope, right? And sometimes maybe we'll be able to. It all kinds of depends on which format we have this in. Ideally, if it was in slope-intercept form, then it would be pretty nice, right? And so neither one of these are in slope-intercept form as it sits right now. Now, if I had to get this one into slope-intercept form, would it be very hard to do? What would I have to do to solve for y? Yeah, just subtract 2. Okay. Now, here is what I would tell you is it is now in slope-intercept form, but it didn't change my slope any. All we did was just solve it so y was by itself. Okay. So sometimes you may do that and you may realize, hey, it didn't really change my slope. My slope here is really 5. Okay, over here, remember when it's in standard form, when x and y are on the same side as one another, we can't just look at this and say, there it is, there's my slope, okay? Like we were able to right here. The a value is in front of the x, then the b value, then the c value. None of those represent slope. But I did teach you that shortcut yesterday, right? So you could solve for y if you really, really want to, but a much easier way is to do the little shortcut. Okay. Now you got to remember that shortcut in order to be able to do it. The opposite of a is 1, so the opposite of 1 would be negative 1 over b is 5. And that's my slope. Pretty quick and easy. You don't have to do a whole lot of solving. Shortcut definitely saves us some time. Okay, we're going to compare the two slopes now. 5 and negative 1 over 5. Are those two parallel to one another? No, they would have to be exactly the same. Those are definitely not the same. Are they perpendicular to one another? Yes. Okay, because if I take 5 and flip it over and switch the sign, it would give me that. Okay, so what we would say here is that these two are perpendicular. And if you would say if you would say no for both, then you would say neither. Okay, I'm going to do one more of those just because sometimes they throw you some curveballs. What you have to pay attention to a little bit here is it looks like it's in standard form, and essentially it is, except these two, the x's and the y's, are flip-flopped, right? And so sometimes they do that just to kind of maybe throw you off a little bit or whatever, but this is my a value, this is my b value over here, and down here, this is my a value, and this is my b value. The a value is always the number in front of the x. So just be careful that if x is not listed first, The a value is the number in front of the x. We don't necessarily care about the c value. We don't use that for the shortcut, so we don't really care what the value is over there. So for the top one, our slope would be the opposite of a over b, so that would be -4 over 2. Should be -2. And then the bottom is -2 over 5, which does not reduce. Are those two parallel? Definitely not. Not the same. Are they perpendicular? Nope. And so then we would say neither. But the thing I wanted to point out more than anything is just that the y's and x's, pay attention to the order that the variables are in. Almost always the x's are going to be listed first and the y's are going to be listed second, but every once in a while you'll see an equation that's just kind of got things mixed around a little bit. Okay, last thing to talk about here. If I gave you an equation, two x plus 4y equals 8. Hey, and you're going to have some problems today where it's going to ask us to write a new equation, and we're going to do two different equations. The first one is write an equation parallel to the original and goes through some point, 612 in this case. Okay, let's go back up to the original equation. Standard form, right? And so when we look at it, once again, we're going to be using the shortcut. This is A, B, and C. So -2 over 4 is my slope, which reduces to be -1/2. That's the slope of the original equation. If this new equation is going to be parallel to it, what's its slope going to be? -1/2. Okay? Don't overthink it. It's going to be exactly the same. And so we're going to keep our slope as -1/2 because the two lines are parallel. They must have the same slope. And we're going to go through the point 612. And then we'll do kind of like we did earlier in the lesson, where we're always going to be finishing in slope-intercept form today. And then we're going to add 3 to 12, and we get b equals 15. Just kind of watch your signs. So that would be a new equation that has the same slope, has a new y-intercept, and it would end up going through that point of 612 that we had. The other one that you will also see here, very similar directions. Write an equation, but instead of parallel, we're going to say perpendicular. To the original. And goes through -2, 0. So the directions are very similar, except two things have changed. Instead of parallel, it's perpendicular, and we're going through a different point. Okay? So the process is going to be pretty similar. If my original slope is -1/2, what's my new slope going to be? It's going to just be 2. Yep, we're going to flip it over, and we got to flip the sign. Okay, so what I would write here is this would be my perpendicular slope. I like to try to do a lot of abbreviating if I can, so just writing out the word perpendicular is not fun over and over again. And then we go through the point -2, 0, and we go through that process. You guys want to do another one of those, or you guys kind of getting the hang of it to get the slope and the y-intercept and write in the equation? You want me to finish it out? Okay, so this is x, this is y. We're going to plug it into y equals mx plus b. We know m, we know x, we know y. We don't know the y-intercept. That's the part that we're still missing. So y is 0. Two times -2 is -4. And then I'm going to add 4 to both sides. And I get b equals 4. And that would be our equation. Okay, these two equations don't really have anything to do with one another, right? And the only thing they have in common is that we went back to that original slope of -1/2. But this one should be parallel to the original -1/2. This one should be perpendicular. So the slopes, obviously, are going to be parallel perpendicular. The y-intercepts are going to be the one that's going to be kind of hard to find, or that you have to do a little bit of work to find. Okay, so we got any questions on any of that?